And they're the answers. And these are tough questions, okay, but really good questions, and they're the right sort of stuff. And those of you going on to take A-level maths, these are absolutely perfect for you. So if I'm solving these, you can't solve simultaneous equations by adding them together. So you've got to go for substitution. And you see you've got this x is equal to this lot. So where I see an x here, I just replace it with the top line. Okay, so that's 3x, but x is this, and then I've got another y. Take away x, but don't take away x, take away this thing, and keep it in brackets. Okay, so I'm going to tidy all this up. Now, can you see you've basically got a quadratic here because you've got a y squared and you've got some y's. So what we're going to do now is play around with this, get it all equal to 0, factorise and solve. Okay, so I'm going to pause the video and do all that. So that's what it ties up to. Hopefully that's what you've got. Now, can you see everything is in the 3 times table? So don't try and factorise that because that would be awful. Instead, divide everything by 3. And you'll get something that looks slightly more straightforward. So front by front, back times back. Now I'm going to use 2 and 3 like that because I want the biggest bit to be positive. So that would give me 9y. Remember that fella acts on that one. So that's a 9y, and then take off that 2y. Okay, so now you've got a solution. So remember, I've got those because I've said each bracket has got to be equal to 0. How can that bracket be 0? How can that bracket be 0? And then you would get your x solutions. And to get your x solutions, you're going to use that initial equation that you had. Yeah, so I'm going from over here, and I'm substituting my y in. So 3 lots of 2/3. Play around with that. Now, when I see this, I see a 3 divided by a 3. In other words, these 3's cancel, which means I'm left with the 2 and add on to the 6 to give me 8. Okay, so that one goes with that one. You need to think of these in terms of pairs. And now do your other one. So x is equal to not 3y, but 3 lots of that because it's here. Add on 6. Play around with it. You've got minus 9 plus 6 give you minus 3. Okay, so that one goes with that one. Okay, this question is about completing the square, which I haven't taught you yet. Really important activity. Some of you might know because you do the further maths. You can go onto a Maths Watch and watch a video on it. That would be good. But I will explain it here best I can. Okay, so this is just the method for how you do it. So the idea is you're going to try and make this into a square, a completed square, which sounds crazy and really hard to describe like this. But your technique is this. Okay, you halve this value. Okay, and now that's squared. Now, if I was to expand that, and let's do that the fast way I showed you. So I would square the front, it would go at the front, so I get an x squared. You can see it's done. I'd square the back, I'd get 16. And then I do that times that, and I double it. So that times that doubled gives you the 8x. Okay, that's why you halve it. Now I want this lot to be like this. So if I expand that out, I would get 16 at the back. But I need 17. So you just add on 1. Okay? And you've now what's called completed the square. Okay, so you've rewritten this in terms of a square, and then this is the other bit to sort of complete it. Okay, but it's all about halving that little bit, popping it there, and then trying to work out what else needs to happen. Okay, And it has loads of applications. Too many that I could to mention here. And this is one of the applications, right? A turning point. I mean, this is the topic that you're going to be working on over the next couple of lessons. A turning point is a part on a quadratic graph. Think sort of smiley face and sad face at the top or at the bottom. So if I was just to sketch one here. Okay, so this bit here, that's your turning point. Okay, it's where the graph turns. Yeah, you see it's coming down, turns and goes back up. And we could have, okay, let's say we had a sad face, quadratic, and negative x squared. There's your turning point because the graph was going up and now it's coming down. Okay, and we can use this to find out where this point is. So we rewrite. So this thing here, y equals, it's the same as this. Hopefully you spotted that. So I'm going to rewrite it in terms of its completed square. Now, this is an x squared, so it looks like this. And what you're trying to find is the lowest point. Now, the lowest point is when this thing disappears, because it can't be negative. It can't be negative because you're squaring it. So you can only make it disappear. Now, how would you make it disappear? Well, you'd have to let x equal -4. Now, if you let x equal -4, that disappears, which means y would be 1. Okay, so the minimum for this curve, which you can see clearly now, it's not this. The minimum for this curve is -4, 1. And it wants its coordinates, so you write it like that. Okay, it's a really clever thing to be able to do, complete the square, because you can do so much with it. So I do encourage you to watch some videos on that on MathsWatch. It's really cool. I'll tell you what I'll do. I'm going to miss out this one because it needs loads of space because it's a really big question. It's a great question, but really big. And let's go down to this one here. So we'll do that one afterwards. And this reminds me of one of the questions that you had in your mocks. It's all about probability, in that we're going to set up some sort of tree diagram, but we don't know how many apples in this case we've got. Okay, so here we go. So I know it's a tree diagram question. There's no reason why you should do, other than with experience. When you start to see this, you'll think about using it. So that's why we do lots of questions. So it's either bad or not bad. So that's bad. Now, when we have the opposite of this one, we often use a little dash. So that's bad. This is not bad. And that's just an abbreviation because we're so lazy as mathematicians. Now, the chance of a bad apple, well, 4 of them are bad, and there are x in the crate, so it must be 4 out of x. Now, not bad, well, if we have x apples, then the chance that the ones which are not bad, okay, must be x take away 4. Imagine if there were like 10 apples. So if there's 10 apples in the crate, if 4 of them are bad, 6 of them are not bad. So you do 10 take away 6. So now we've got x apples. So it's x take away 4 out of however many apples there are, which is x. Okay, so that's your first bit. Now I'm only interested in 2 bad apples. So I don't worry about this. I don't even need it. So I actually need to go along up here. Okay, I want them to be, I want another bad apple. So this b dash down here, this not bad. I'm not even going to bother to explore it because I don't need it. So I'm up here. So if I've taken out 1 apple, and that was the chance of it, which means if I now am up here, well, if there were 4 bad apples, well now there's only 3 bad apples. But how many apples are left in the crate? Well, there were x, but you've just taken 1 out, so it must be x minus 1. Okay? So chance of your first bad apple was 4 out of x. 1's gone, which means now you've only left with 3, and you've taken out an apple, so it's only x minus 1. And you want to know 2 bad apples. So in other words, it's bad and bad. So it's bad and bad. Okay? Yeah, but it tells you it's 1/11th, so that is 1/11th. So and telling me it's times. So I've got to play around with this now. There's nothing to do with probability anymore. This is just about algebraic fractions and mucking around. So how do you multiply fractions? Well, just go along the top, go along the bottom, should we chuck that 11 up there? So times both sides by 11. So 11 times 12, what's that, 132? I always find that times table hard. So 11 times 12 is up there. And then this thing here, let's chuck it up here. In other words, I'm timesing both sides by it, so it disappears from here and it ends up over here. Let's expand it and get it all to one side. And I think we've got what we want, although I can no longer see what we want. Let's just have a little peek. Was that what we wanted? Yeah, there you go. X squared minus x minus 132. Yeah, just there. Okay, so that's that bit. Now what's the next bit? Find x, the number of apples in the crate. Well, unsurprisingly, we're being asked to solve this. Okay, that was always going to happen. Now, if you think about how did we make that in the first place? Well, that 132 came from 11 times 12. So that's actually what I need. Can you see they differ by 1, which is what I was after. Now I want the middle bit to be negative, so make your biggest number negative, and that will work. So x is either negative 11, or is that possible? Can you have negative 11 apples? Or x is 12, which means that must be the answer. Right, so now to this question, which is going to take us about half a day. So if you had a go at it, brilliant. If you haven't, sort of try and stay with me now. And we'll see if we can solve it, but it's a big question. Okay, then here we go with this one. So step 1 is to try and find this one AC, really. So I'm going to just get rid of that mix, that's kind of in the way, and let's pop a line in. So this is all about the sine rule and the cosine rule. So we are looking at AC, and so I'm going to use the cosine rule, okay? So cosine rule is A squared, and that's the line opposite the angle that you're looking at. So it's A squared equals B squared plus C squared minus 2BC cos of that angle. All right, so that's what I'm doing, but I'm going to do it in terms of what we've got here. So here we go. Okay, so we've got A squared, so that's my A, opposite the angle. Notice, so we always start and finish with the pair that match each other. And then your other two bits are just these two sides. So this is now just about you playing around carefully with your calculator. That will all come down to 13.34. I've done this one in advance. Okay, I was over here for half an hour. So using your calculator carefully, you're going to plug all that in. Don't do it all in one go. You can write down some in between steps. That would be a good advice to get there. So if you don't get that, write a little bit more down and show some in between steps. So that is that bit there. So let's stick that in. All right, now my next bit is I want to find out this angle here. Now we know the whole thing is 150, but we don't know what this angle is. So that's what I'm going to try and find now. This is all to try and help me get into the bit I want. It's a crazy question. So we'll call that theta. And I'm going to use the sine rule here. So we're going to go sine theta over, again, it sort of matches up. And then you need to set that to a pair that you know about. So you know about this pair. This is why we found AC. Okay, play around with that. So chuck the 14. 14 would go up here. So you'd be typing into your calculator something like 14 sine 70 equals divided by 13.34. Get an answer, and then you would inverse sine that. And eventually you're going to get 80.46. Okay, So the 14 jumps up. So you're typing in 14 sine 70, press equals, divided by 13.34, press equals, then do inverse sine, and you'll get that little bit. So we've now got this bit here. So this bit is, if I rub that out, so this is 80. Now remember, we knew it was 150 to start off with. So we've now got that little bit. So we can do 150 minus 80.46. And that is giving me 69.54. So that's that one now. 69.54. So remember, we're still trying to find this BC, or X if you like. Now, can you see you've got two sides and the angle, which means it's back to cosine rule. Now, can you believe it? So this BC, I've labelled it X, so I'll use X. So you've got X squared is equal to 8 squared plus 13.34 squared minus 2 times 8 cos of that angle. Play around with all that, type it all into your calculator. I mean, you can type it all in one go if you're careful, and if you know how to use your calculator properly, and eventually you will get down to 12.94. Now, if you did that by yourself, take a picture of your work and send it to me. That's incredible. It's such a long-winded question, and to know where to go as well. Super impressive. Anyway, we're done. Go and have a lie down now.